Welcome back, Precalcers. Today we're looking at 1.5, analyzing graphs of functions. So, right off the bat, I'm going to try to blast through this stuff because a lot of it's really similar. And more today than ever, you guys have to be open with me. So, what we're going to look at is just all of these important characteristics. And we can say characteristics, and key features. Okay, there's only one section here that we're going to see, but they're going to be a bunch of small sections. First off, is y equals some equation any different than f of x equals some equation? No, they're the same thing, right? Normally, and especially on the AP stuff, you'll see the graph of y equals f of x is given, and they word it really strangely because they say y is the graph of this. Now, they're essentially interchangeable, but y equals or f of x equals, same thing. Cool with that. Do I need to write it down? Okay, with this, I want to know quick if it's in, I don't know, if it's brown, don't write it down. Okay, if you can think of a way to, hold on. Nope, there's not alliteration that I can think of with pink yet. But here we go. I just want you to tell me, is this a function? Why not? Okay, piece of cake. Check it out. There's our first one. Ta-da. Vertical line test. You will never see me write these three words again. Why not? What am I going to write every time moving forward? It's the VLT, 100%. Okay, if it's a function, explain to me what the vertical line test does. Good. A vertical line must only touch one time, maximum. Now, do I write that? Vertical line must touch the function only once, at most one time. Okay, we've all seen it. This is a graphy version of can you solve it uniquely? 1x, 1y, that's it. Okay, vertical line test happens. These ones are a little bit harder. Domain and range. Now, I'm going to try to write this. You guys have written sets and things a few different ways. Anybody remember set builder notation? Okay. All right, so let's take a look. It's either the squiggly bracket, the curly bracket, or not the curly bracket. But let's look. We're going to just do this with an example. Remind me real quick, the domain is the set of all what? X values that go into my function. And notice my curly brackets. And the range then is the set of the y vals. Now, alternatively, maybe a better way than just thinking x and y, because that locks us into two variables. The domain is what can we put in, like the input values that work. And the range is what then? Output. The output. Okay. We should do a domain and range really quickly. So I'm going to actually graph one. I'm going to sketch it, but we're going to graph it kind of nice. And then we'll call this an example, I suppose. You do not need graph paper unless you are just dying for it to be perfect. But here we go. Addison, what's your favorite number? 4. Okay, so I'm going to start at -4. And I'm going to put an open circle right here. And then I'll say this value up here is, I don't know, I like 7. And we'll say that's close, so we'll say that's -7. And what's this number?
3.
Sure. It's not to scale, but I'm good with it. I have put zero thought into what this graph needs to look like other than I put some numbers on it. So first off, and I'll wait because I can still see people drawing, so I'm going to hold off. Somebody might have thought it was food, it's stickers. All right, is that a function? How do you know? What's up? Okay, vertical line test. So I'll go ahead and take the liberty of, what should we name this function? I'm not writing yay. Good choice. F is a natural first kind of step. All right, what do you think I'm going to ask you about F here, based on where this example is within our notes? So characteristics is our main idea, right? Then we talked about VLT. Now, oh my gosh, I want the domain and range of this function F. And I'm going to give you guys 60 seconds. I want you to find me the domain of F. And I'm going to write it 2 different ways, and we'll talk about those notations. I'm going to leave a little space, but I also want you to tell me the range of this function F. Cool. Talking with your neighbors. Being okay with being wrong. Maybe. I don't know that you'll be wrong. I'm going to give you 1 minute. I want you to try to answer this using your brain, your neighbor's brain, preferably while it's still in there. But cool. 1 minute. I want to see what you come up with. Number 4. Who dat? You. Okay. I think the domain is 0 to 4. Anybody agree with me? No. All right, let's get another input. Number Dolan, domain. Help me out.
Negative 4 is less than x is less than or equal to 3.
Love it. Okay, that can be hard to follow. I saw somebody do this yesterday, or just a minute ago. When you're thinking about domain, you're thinking of the x values, right? And if I drew an x equals something, it's a vertical line. Everybody cool with that? So the idea of running your protractor across your page is perfect. Like, this makes domain of a graph so easy. All I need to know is, if I let this go forever, will it hit somewhere? Right now, am I ever going to hit the graph of my function? So you said yes, Basil. Convince me. Why yes? Okay. Do you know what I'm asking? Okay, so check it out. Right now, does this function ever go beyond this? So if the function just completely stops here, is there any chance that this red line right in here is ever going to touch the graph? Where's the first place that I kind of start touching it? It's a little weird at first. Okay, do I actually touch it? No. How can you tell I don't actually touch it? Because it's open. It's not a closed point. Open means I get arbitrarily close. That means that if I said, hey, we're going to start really close to negative 4 on the right side of it on a number line, give me something close to negative 4. Negative 3.5. Can I get closer than that? Yeah. Negative 3.9. Can I get closer than negative 3.9? Negative 3.9, and we're never going to stop, right? Because we're going to go forever, because I can get as close as I want to. Add another 9, we're closer. So as we look at it, we start here. Am I still touching? Somewhere, at least once, am I touching the graph? Still touching, still touching, still touching, still touching, still touching, still touching. And here, it gets weird again. Do I still touch? Yeah. Will I ever touch to the right of it? Okay, so I heard 2 different types of answers here. And I know which one I prefer, but I'm not going to let my biases come in here. Okay, domain. 2 ways to write this. The first is with these lovely bad boys. I've written the first part of like a legitimate English sentence with math notation. Can somebody read me the first 3 marks? The set of all x, and what's that vertical bar? Such that. Okay, Dolan hit it spot on. He said that, okay, negative 4 is where I start, and x is always bigger than that, but it can't be equal, so we'll just say negative 4 is less than x. And then x, I can use all of them until I get to where, Wisha? Till 3, and can I actually touch 3? So how do I indicate that I can touch it? Or equal to. Okay, this is set builder notation. I like this one. I told you a second ago I wasn't going to tell you my biases, but there they are. This is the one that I prefer. Now, alternatively, there's this interval notation, which when done correctly, it's going to look a lot like this. Because if people struggle, anybody hate the compound inequality? No. Okay, if you do, or just want another option, the alternative, and I'm going to be kind of fast and loose with this just so you know, I would use curly brackets normally, but your book doesn't. We could say x is in, there's an interval here, a range that we just wrote down. You said it was from where? Negative 4 to how far to the right? 3. Do I include 3? Bracket. Do I include 4? Or negative 4? Parenthesis. These say the same thing. You should, because the reason that so your book won't do this, and realistically, I would want to do it like this. is how I'd prefer to write it. But the reason that I want you to use the x in the set of is because if I just say, hey, here's my domain, and it looks like this, what might somebody confuse it with? A point. But if you use that x in the set of, you're going to, you won't make that mistake if it's very clear what you're talking about. Okay. I would encourage using the in the set of, because the interval stuff, yep, people get goofed up. Okay, how about the range? Lowest value? Instead of a vertical line, I'm imagining a what? A horizontal, because y equals is a horizontal line. So if it didn't click the first time and you were too shy to say something, let's get it to click now. When I go down here to -8, am I touching my graph? No. I'm going to start working up. We're all going to get real loud as soon as I hit the graph, okay? Have we done that in here yet? No. Okay. Whenever you think my range starts, I want you to get loud. Okay, we're going to try that again. Christine's still doing fantastic. All right, you ready? One more time. All right. So sorry if anybody's watching this with headphones. Okay, we start at -7. Do we include it? Did you hear me yell? Oh, fantastic. Okay, should we redo this real quick just so Ms. Hanish can also see? All right, so when do I start touching it? I showed them how to get loud is what happened. So we start at -7. Do we include it? No. Okay, am I still touching? Still touching? Still touching. Until I get to which y value? 7. So for this one, we just identified the domain. Piece of cake. Or sorry, the range. The range is the set of what values this time? They're the y values such that we just found that y's only spit out between which two numbers? So -7 and 7. So -7, and then we'll deal with the other ones, a y and a 7. Is y greater than or equal to -7? How do you know that? Oh, it's open. Okay, good. If I don't fill in the circle, I don't underline it. How about +7? Greater than?
Less than. Huh? Yeah, what you're writing.
So y is less than 7. I understand the confusion there. Yep. We were just reading it backward. Nobody was wrong. We just said it differently. 7 is greater than y. That's the same thing. Yes, miss?
The first one, the -7, I thought I heard you say it was greater than y.
Did I say -7 is greater than y? Okay. Thank you for that. That might have been where the confusion was. Yeah, so I think I said it. I might have said it incorrectly. Check your page for me. Do you have that y is greater than -7? Okay. Don't know why I misspoke it. Good catch. That's where the confusion was. I was wrong. Okay. Cool with this. Do it in an interval for me. I want interval notation as well. Now, we are going to use y. And gosh, dang it, I just am terrible at symbols. What is this? In the set of. Give me the interval. Write this in the interval instead, and I just want to see what you guys come up with. Addison, you confident in your answer?
Just this one?
So here's the thing. If Addison's wrong, who's hurt in that situation? Addison's pride might be a little hurt. Am I here to teach you how to be prideful? No, I'm here to make sure that we can all do what? Math. I want you to be proud of what you do, but I don't care if you're, don't be embarrassed. I'm going to do this all year long. Cool. All right, Addison, let's check. Addison said y is in this guy. -7 to 7, parenthesis at -7, bracket at +7. Is this correct? Great job, Addison. Cool. You got it. In the set of, just make sure you include that. Cool.
I put the inset on the bottom.
I saw that. Yep, you're good. Cool. All right, domain and range. Doable? What if I gave you a hard one? Should we do one more?
Sure.
Okay, you do not have to write it. This is a talking problem. We're going to put some numbers here. -3 and 4. And you don't have to draw this. I'm just going to. -1. Cool, check it out.
Oh, my god, it's those thingies.
I want you to talk. Speak it out. You can draw it if you want to. But I'm going to give you guys 60 seconds. Do it in your margin if you need to write it down so you don't forget. I want the domain and range of this. Where's the first value I start at? So -3, what about it? Is less than x. It is less than or equal to 5. That covers this section right here. Just kidding, it's 0. Purposeful mistakes to add to learning. Cool. -3 to 0. Everybody cool there? Now, I'm not going to use the union symbol here. I'm not going to use the, no, I'm not even going to close it either. I'm not going to use it because I'm not talking an interval. I'm going to physically word and. What else? Now, I told you earlier that I prefer this. I don't know that that's really true. As long as it's clear that you're using interval, I would much prefer that. Okay, in Algebra 2 class where people aren't comfortable with interval notation, this is the one that we use. But should we do this one in interval real quick? X is in, let's see this first interval on the left from -3 to 0. Is it open on the left or closed? So open. So we start at, not 0, we start at -3. We go to where?
0.
And here? Union. There's no tail on this U. Where do we pick back up? 4, that's open. And how far do we go? We done. Same values, different written. I like this one because it looks nice. If you have the X in the set of, I think this one, we avoid all that possible confusion. I don't care which one you use unless I specify an answer. Okay. What about the range? So it starts at 2. Does it actually get used? What's the y value right here? 2. Okay, so it does get used. So y is always greater than or equal to 2, or 2 is less than or equal to y if you'd rather. Simultaneously, what does y never get bigger than? And it's closed? 5. We done. Harder problem. Like it looks harder. Maybe it's a little harder. Same exact idea though, right? Cool. We good with those? What's a 0? Ooh, love it. Here we go. If we're talking on a graph, how would you interpret a 0? Like, can you see any zeros on our graph here? How many?
3.
Interesting. I like that I hear 3, and I think I know where the third one is. If you counted 2, you're probably counting those numbers. Matilda, did you count this one? So, you say yeah. Okay, so it's a 0 for a different reason. But let's make sense of it. These are 2 that I'm after. Maybe zeros isn't perfectly clear. What am I crossing here, or intercepting? Okay, let's call the x-intercept. So graphically, this is how I would refer to it. The x, and I'm just going to say intercepts in general. And if you have x and y, if you already started writing, intercepts. Okay, for the intercepts, care way more about the x-axis than the y-axis most of the time. So here we go, x-intercepts. X, and there's usually a dash, but it's going to look dumb if I do that. X-intercepts. Okay. Every function, if you want to know the x-intercept, it's where the y value is what? Louder and prouder. 0. If you have 0 on the y-axis, you're at the x-axis, and you must be intersecting it. Okay, so if we're looking at this, we'll just say where my whole function, f of x, is equal to what? 0. Okay, that's it. We can put in other words type of situation here because there's a lot of really important stuff that we're going to see. Specifically, just an e.g., not really a true example, but it's just like to demonstrate this. If f of a is equal to 0, then here's the challenge. Can you tell me the x-intercept? What x value do we plug in? When I evaluate f of a, what am I saying? Find the value of the function when x equals. I'm talking really fast. What x did we plug in to get it to spit out 0? Yeah, good. A, comma what? Is the intercept. And it's a weird question to word, but I think it's clear when I write it, but I didn't want to just give it away. This says plug in A, it gives me 0. This is my intercept. Now, there's some more stuff that we're going to get from this once we get into the factoring chapter, but we'll deal with that when we get there. Okay, other names for it? Do you guys know what AKA is actually short for? Also known as. Okay, when I talk about the x-intercepts, I already heard a few of them. Can you tell me some of the words you said? Roots, solutions, and then this one, I will spell it differently every time because they're both acceptable. Zeros. They're the same thing. Zeros can have the second E or not, and they're both correct. Cool. I don't know that we're going to talk a lot about it. Is there another type of intercept, though? We should, since we're here, do you guys have space in your notes if we do it right here? The y-intercept. How would you, using similar kind of vocab, what would you do? 0, comma, and I'm just going to go really quickly. 0, comma, f of so if we're at the y-intercept, what is my x value always? Whoa, I shouldn't be 0. What am I doing? Time. Everybody have 0 here? If you're writing in pen, I'm going to change it to a b. B, comma, my bad. Sorry about that, guys. And to get the y-intercept, I'm always going to plug what in for x? 0. There's, I don't know why my 0 was there in my head. B, comma, f of 0 is what it'll always. Am I right? I feel like I'm goofy here. Why am I goofy? There's something wrong with it. Well, one, the B is ugly, but the B is the x value, right? What should it be? 0, comma. So check it out. Mistakes. This is more of a writing mistake than anything. I'm not going to erase it on mine. I made the mistake. We're going to own it. Help me write the order pair for any y-intercept. 0, comma, B. Cool. Yeah, weird. Sorry for the hiccup, guys. All right. Y-intercepts, we'll deal with them more soon. Okay. We talked about what it meant. I already erased it. For a function to be increasing earlier, right? How would you define it? So we'll talk about increasing and decreasing. And these are all key features, trying to go through fast. Increasing and decreasing. If I wanted to formally define this, and I'm just going to do the increasing part, and I'm going to encourage the decreasing, you just change the one inequality. But let's think this out. Increasing, and we'll define this one here. And we're going to practice our fancy stuff. F is increasing if, what does this symbol mean? Okay, we're going to use this one all the time. For all. It's not a Holloway symbol, that's a real symbol. For all, I need 2 values. Let's call it x1 and x2. Such that, and I use st for my such that so the vertical bar doesn't confuse me with other stuff. If you give me x1 and x2, and you tell me furthermore that x1 is smaller than x2, just to ensure that they're not the same number. And remember, I'm going to do this in brown just to think about. I'm going to pick 2x1 or 2 x's. Here's x1 and here's x2. If my function is increasing, going left to right, negative to positive, it goes upward, right? This is increasing, I think. What would you find if I asked you to compare f of x1 and f of x2? If x2 is bigger than x1, this guarantees, if it's increasing, that what? Okay, I heard 4 mumbles. I didn't hear anything clear, though.
The y value is also.
The y value is also bigger. Can you use the language that we have here? F of, what's the bigger one? Or we'll do it the same way. F of x1 had better be less than f of x2. Addison, I think that's what you were saying. I might have changed it around. But if you pick a bigger x, it gives you a bigger y. That's all that it means to be increasing. I'm not going to write the other side. How would you change this if you wanted it to be decreasing? Yeah, if x2 was bigger than x1 like it is, a decreasing function, you would see that f of x2 is way smaller than f of x1, right? Okay, now you can check this. That's fine. Using the tangent lines like we did in that problem at the start of class, equally fine. They're the same idea. Cool? All right. Does a function have to be increasing or decreasing? Could it do neither? What does that look like? Good. It's a straight horizontal line. Cool. It doesn't grow, doesn't shrink. It's just constant. Okay. Love this. I have an idea. That was the thing there. Okay. It was funny in my head, but you guys don't know what I'm thinking, so. Cool. Let's talk about maxima, and we're going to use a different word. Do you agree that if it's a minimum or a maximum, it's one of the more extreme values of my function? Because of that, do you guys know what word I'm about to write?
Oh.
Extrema, or extrema. I say extrema. I honestly don't know how the right way to pronounce it is, but I'm stuck in my ways, so good luck. Extrema. That's just a plural of the extreme values of my function, right off the bat. Now, you can have one of, there's actually several types. Rather than writing them all out, we'll define them, but we're going to draw a graph that has several different types of extrema on it. So, we've already looked, and we're going to see if we need words, but I want to draw a graph that, I don't know, does something like this. So we have, it's going to have to be closed on either end so we can talk about these things. Let's say it's this, this, and this. I didn't think about these numbers at all. I don't even put a scale on here. Don't care what the numbers are. All I want to be able to do is pick out the types of extrema that we see. Okay. First of all, how many extreme values do you guys see? I see 3. Okay. If you see 2, I bet we see some of the same one. Is this an extrema? It will be, and it is. Here's another one. And here's the third. Okay, I agree with you. Does everybody see that those look, compared to everything around them, a little bit different? Now, there is some overlap here. If you guys remember, if I say a 4-sided polygon, and this is not Precalc right now, it's an old geometry example, but that's okay. A 4-sided polygon that has 4 sides that are the same, like the same length. Did I just tell you to make a square? Did it have to be a square? It could have been a rhombus, right? So I like that idea. Rhombus fits all those characteristics, but it's not a square. So there's some overlap that we have to be careful with. This one right here, I'm going to try to sneak these in. We can be more specific if you'd like. Is this a maximum or a minimum? Maximum. Now, one thing we're just going to draw, I'm going to draw a neighborhood around it. And by that, I mean, I'm just going to use some gray here. And you don't have to draw it, but I just want to see. In this neighborhood, is the value of my function bigger, the y value, bigger than everywhere else in that circle around it? Okay, so it is locally large. But this one's even more than locally large. Is there another place anywhere on my whole graph that's bigger than this? So there's 2 words that we can use for this. I don't care which one you wind up using. We'll probably go use both of them. This is either a global, or the alternative is absolute. Maxima. And maximum, rather. Okay. I don't want us to write this one, but I want the idea to stick in your brains. It's also local maximum, but it's better than just local. It's bigger than everything. It's local and global. Cool. This one right here is a minimum. Everybody on the same page there? This is a minimum. Any adjective you'd like me to put in front of minimum? Is there another spot anywhere on the graph that's smaller? No, so what do we say? Global, and I'm not going to put it this time, but it could be, other word? Absolute. Is it also a local minima? Yeah, it's smaller than everything else directly around it. It just happens to be smaller than everything everywhere. Okay, this one is the last little piece. It's a minimum, but it's not global. So relative is one of them. I use a shorter word, local. Or if you'd rather, and you probably saw this word last year, relative. Whether it's a local min or a relative min, same thing. Cool. All right. We cool with this? Am I going too fast? Let me see how much more we have, because I'm trying to remember what else we could possibly have. Did it. We did it. Oh, love it. Here's the deal. And by the here's the deal, I mean here's democracy. Do you want me to give you a short assignment now that covers the stuff that we've seen so far? Or do you want to keep noting for the next 7 minutes, and then we'll finish the section and then have time in class for homework tomorrow? That's just going to be more than today, but added on.
Second option.
Tomorrow.
Nobody wants homework tonight?
No.
The Cowboys play tomorrow.
Yeah.
Okay, all right. Your funeral. All right. So, what? Indeed. Go Cowboys. They are going to be bad. Not really funny in my mind, but okay. All right. Couple more things. This idea is not just a characteristic. I'm not offended. It's not so much as a characteristic, but it's something we're going to use all the time. Average rate of change. Okay, you will never see me write this again either. AROC is how I write this. AROC is what I'm going to ask you for every time I ask for the average rate of change. Was your sigh exasperation about this, or was your water just really refreshing? Glad to hear it. Do you guys remember average rates of change? Okay. I'm going to try as often as I can to default to just using a picture to make sense of stuff. If you want the word of your version and you feel that I'm about to move on without giving the word of your version, what do? Yeah, or tell, like I'm fine to write it. Okay, check it out. I want us to consider, and I'm always going to default to the first quadrant, like 90% of the time. I'm going to put some function here, whoop, and it looks like a part of a parabola. Neat. And I'm going to put 2 points on my graph. Now, the points I'm going to pick are awesome, because this point I'm going to say is x1 and f of x1. So it's no different than if this was at 1, I could say it's 1 comma 4 if I evaluated it, right? Okay, powers of deduction. I'm going to put a point here. What am I going to name this one? x2, but check it out. I'm doing it very specifically. I'm going to put it underneath here. X sub 2 and f of whatever that is. Okay. This is not going to feel like it's the same thing, but number 6 on your stuff last night, conceptually, you were doing this exact same thing. You didn't notice it. You might after today. You definitely will when we talk about it and we go through the problem. Can I draw, do you guys agree that from here to here, my function decreased a little bit, it looks like, and then it changed to increasing? Okay, if I want the average rate of change, if I wanted to sketch a secant line, something that touches it twice, can I draw the line through these 2 points? Okay, and if we think about a line existing, what are maybe a couple of the things that I might ask you to find about said line? Okay, we're going to stop right there, because there's others, but that's one I care about. Could we find the slope of this line? Okay, do you remember what this line is called that touches twice? I might have just said it. This is the secant. Secant line. Okay, through these 2 points. Here we go. The average rate of change, I'm going to say AROC, is equal. I'm going to do 2 different things here. We're going to do it the wordy way, which, what letter do we use for slope, by the way? M. And I'm finding the slope of what kind of line did we just say? So check it out. M subsecant is fine and dandy. Conceptually, I want you to have this ready to roll. How would you actually find the slope given those 2 points? So I don't see y written anywhere up here. F of x2 maybe? Minus?
Why isn't it just Y? Or, yeah.
Because we're trying to really drive home the function stuff. It would just be some y value, right? y1 and y2. I'm just really stressing that, hey, we get it by plugging it in. Minus f of x sub 1. What must be downstairs in the denominator? x2 minus x1. Okay, the order doesn't change. This is how one calculates out an average rate of change. Let's do one. Nobody's taking physics right now, huh?
No.
Okay, so we're actually going to pause right here. Tomorrow at the start of class, we're going to do, we don't have physics this year. Tomorrow at the start of class, we're going to do an example of this. We're going to see a physics type problem. Okay, with that, we have like 3 minutes left.